Hello everyone, Smail is here. Today we're going to study 7.2 connecting intercept and linear factors. You can find all the lessons on my website alfaramath.com. Okay, today let's start the lessons. Okay, let's start with the intercepts, connecting intercepts and linear factors. Okay, so first of all, what's the meaning of x-intercept? X-intercept, where is your function intersect with the x-axis. So if you have x-axis, so let's say I have this function, so this one is the intersect. So this one is a linear function. So the linear functions means we have only one x. Okay, so if you remember the formula of the linear function, it's mx plus b. So we have only one x, which is one x-intercept we have on our graph. Okay, and here in this equation, which is the quadratic function, the quadratic function is, if you remember, x squared plus bx plus c, blah blah blah. So okay, so as you can see here, we have 2x here. So 2x means we have two x's, okay, that intersect with the x-axis. Okay, here inshallah in the future we're going to learn when your functions intersect at three x's. Okay, when we have x to the power of 3 and four x's intersect with x to the power of 4 and so on, inshallah, in the future. Now let's start here first with how we can uh, graph using the intercept form. We know that we have three forms, okay, of a quadratic functions. The first form is the standard form, okay, and the second one is the vertex form, okay, and the last one is the intercept form that we are going to learn. Standard form in this way, ax squared bx plus c. Vertex form is a x minus h to the power of 2 plus k. What is the intercept form? The intercept form, if you go here, this one is the intercept form. Y equal, okay, a x minus b x minus q. Okay, so what's p and q? P and q are my intercept. Do you remember here I told you I have two x-intercept? Okay, p and q, this one is my first intercept, q is my second intercept. So if I have now let's say I have a function, okay, this is a quadratic, okay, so this one is the first example, p, and this one is q. Okay, so I have p and q. Okay, who decides? Okay, let me just grab and give you a new one. So let's say p and q. Okay, and this one is y. Okay, now I need only to find one point, okay, which is the vertex. Okay, maybe sometimes the vertex here, so my graph will look like this. If my vertex here, so my graph will go like this. Who decide? Okay, who control the vertex? Okay, when it's upward, okay, or when it's downward, okay. The one who controls this one is A. Okay, so A always, okay, or A always, if it's A positive, okay, so that's mean it's upward. If A is negative, okay, so that's mean is downward. Okay, now here the x coordinate, the vertex, the average p and the q. Okay, so we need to find the average to find the axis of symmetry. Okay, then we use the point that we find and block this point in the y and the function here to find the y, then we can graph the parabola. Okay, now look at this example to understand. So now, first of all, we need to find p and q. So p is 4, q is -2. If you say that, okay, it's fine, but this is not the actual answer. Always in y-intercept form, okay, sorry, in intercept form of the quadratic, always p and q opposite sign, okay? Always opposite, how we can write opposite? Okay, it's fine. Opposite sign, okay? Always opposite sign. So if this one positive 4, so you have to take it x equal -4. If this one -2, so x equal +2. So always you take the opposite sign. Okay, so now after we identify the x-intercept, so the first x-intercept is -4, okay? The second x-intercept is 2. Okay, now to find the axis of symmetry, I need to find the axis of symmetry. So the axis of symmetry, okay, which is considered as x, because we know that axis of symmetry is represented by h. H is x, okay, which is we need to find the average. So -4 Okay, negative 4 plus 2 over 2. Always, this is the rule. P plus Q over 2. Always like that. This is the rule to find the axis of symmetry. Okay, so now negative 4 plus 2 over 2 equal negative 1. So now where is negative 1 on my graph? This one here. This one is my axis of symmetry. This one is my middle of my graph. Okay, so now I use this point here, okay, and I replace it with every x in my function. Okay, so now look here to find the y coordinate. So negative 1 plus 4 equal negative 1 minus 2. Okay, so negative 1 plus 4 equal 3, negative 1, negative 2, negative 3. So y is equal negative 9. So now my vertex is the x axis of symmetry, and the y coordinate. So where is negative 9? Here is negative 9. So now I can graph my functions using only 3 points. Here in intercept form, it's easy to graph my function because the function always give you the x-intercept, okay? And it gave you the vertex, okay? Now, let's go here to take another example, okay? Let's have a look in this example. So the first step here, we need to find the x. So the first x is x, always take the opposite sign. So x plus 2, so it will be x equal negative 2. So the second x, negative 5, so it will be x plus positive 5. So now let's plot these x-intercepts, the zeros. So negative 2, okay, and positive 5. So if this one is 1, this one is a 3, this one is 5, this one is 7. 1, 2, 3, 4, 5. So it should be here. Okay. So now these are my x-intercept. Okay. Now let's graph. Let's find the center, the axis of symmetry. Okay. To find the axis of symmetry, which is x, or let's say it h. Okay, is equal. Okay. We need to find the average. P. Okay. Negative 2 plus 5 over 2. So negative 2 plus 5 equal 3. 3 over 2, which is in decimal, 1.5. So now my point is 1.5. So where is 1.5? This is 1, so this is 1.5. So it should be somewhere here between 1 and 2. So my point should be somewhere here. Okay, now after we find h, we need to find y, which is k. Okay, we need to find y. Y is equal. Now let's plug this one here in my function. So it will be 1.5. Okay, sorry, 1.5 plus 2. Okay, and 1.5 minus 5. Okay, now 1.5 plus 2 is equal 3.5. Sorry, not 3.5. Okay, and this one also is negative 3.5. Okay, so 3.5 times negative 3.5, I think it's 12.25. Okay, so now this one is y. So now my vertex is 1.5 and 12.5. So 12.5 is somewhere here. Okay, so now I can graph my functions, and my function should look like this one here. Okay, after we know how we can graph the functions, you can now start graph practice on these two questions. Okay, now let's rewriting from factor from the intercept form to standard form, which is easier. So we know that the standard form is ax squared plus bx plus c. Okay, so now what we need to do, we need just to do FOIL, which is distributive property. Okay, so x times x, x times negative 2. Okay, now y equal. Okay, first of all, the number that here, just ignore it. Okay, so just ignore it. Don't just think it's not there. Okay, and keep it, write it down. Now, open a big bracket. Okay, so x times x is equal x squared. X times negative 2 is negative 2x. Okay, 2 times x is equal to x. Okay, 2 times negative 2, negative 4. Now simplify. If you have a like term, simplify, add them. If you don't have like term, so just keep it. So now negative 5. So do I have a like term? Yes, I have like term. I have negative 2 and positive 2. So positive 2 and negative 2 is equal 0. So we cancel them. Now it's remain x to the power of 2 minus 4. Now use distributive property. Okay, negative 5 to the power of 2 and negative 5 times negative 4. So negative 5 times x, negative 5x squared, and negative 5 times 4, negative 4 is equal positive 20. So now this is my standard form for this equation. It's similar what's happened here in the example. If you look to the example, x times x is equal x squared. X times negative 7, negative 7x. 2 times x, 2x. 2 times negative 7, negative 14. Okay, so now let's add the like term. So I have negative 7 plus 2 a like term, so it's equal negative 5. So I keep x squared, I keep negative 14. So now I use the distributive property for 3. So 3 times x square root, sorry, square, 3x squared. 3 times negative 5, negative 15x. 3 times negative 14, negative 42. Okay, let's take one more example and finish this because it's easy. So now x times x is equal, okay, x times x is x squared, x times negative 1, negative x, okay, negative 7 times x, negative 7x, negative 7 times negative 1, positive 7. So y is equal x squared. Okay, let's add the like term. So the like term, we have negative 7 and we have negative here should be 1, right? Okay, so negative 7, negative 1, negative 8, x plus 7. So now this one is my standard form. Okay, now you can start solve practice on these questions, and if you practice, you will be able to solve. Now, if you read the question here, write each function in standard form, determine the x-intercept and the zeros of each function. So as you can see here, the zeros of each functions, always we take the opposite sign of h and k. So here x is positive 1, so it should be x negative 1. Here x negative 3, so it should be x equal to 3. If you look here, so this is the first x, 0. This is the second 0. Now, convert this one to standard form. So to convert this one to standard form, we need to use distributive property. Okay, so if you use distributive property, that's like what we learned. So it will be x squared, okay, x times negative 3, negative 3, x, positive 1x, positive x. So positive 1 times negative 3, negative 3. Now add the like term, so as you can see here, so x squared minus 2x minus 3. Is it similar to this one? Yes, so this one is my answer. Clear? Okay, one more questions here. So as you can see here, we need to find the zeros. Okay, here, if you look to the question, okay, if you say that the first x here is equal negative 2, if you say here the x here is positive 5, this is wrong. Don't do that. Why? Because if you look at this bracket, it's x plus 2. There is no any number beside the x, okay? And if we don't have number beside x, we can use the way that we learned. But if there is a number like 2 here, you can't just say, can't just ignore it, okay? You can't ignore it. So what we need to do here, so to do, what we need to do, okay, first, what we need to do, we do that. 2x minus 5 equals 0. So what we need to do, we need to take the bracket and equal this bracket with 0. Now, just solve this equation. So to solve it, okay, we need to plus 5 for both sides. So we cancel this. So now 2x equal 5. Okay, now solve this one divided by 2, divided by 2. So x is equal what? 5 over 2. So now this one is my x. Okay, so the first 0 is x negative equal negative 2. The second 0 is x equal 5 over 2. Okay, so now if you need to write this one in a standard form, okay, so let's write it in a standard form. So as I told you, you keep this number for later, okay, and then you open up a big bracket. Now, 2x times x squared, it's 2x squared. 2x times 2, it's equal 4x. Okay, now negative 5 times x, okay, which is equal negative 5x. Okay, negative 5 times 2 is equal negative 10. Now add the like term. Yes, we have like term, positive 4, negative 5x. Okay, so now y is equal negative 3, 2x squared minus x minus 10. Now let's use the distributive property for this one. So negative 3 times 2 is equal negative 6x squared, negative 3 times negative x, positive 3x, because negative with negative, okay? And negative 3 times negative 10, positive 30. So now this one is my standard form. Clear? Okay, I hope this one is clear. You have here some practice question. Try to practice find the zeros and write them in a standard form. Okay, so the last part of this lesson here, okay, writing quadratic function given the x-intercepts. Okay, so here this one, it's similar to the lesson 7.3. Okay, so I will just keep it for 7.3 to explain that. So I don't need to explain here again, and I explain it again on 7.3. Okay, but in general idea, okay, if you look here to find the zeros, we do the same thing. X negative a, it will be x equal a. X minus b, it will be x equal b. Okay, and same thing here. Sometimes the question will give us k. So if you give us k, we do the same thing. K will never change anything on the zeros. Okay, if you look at this example here, so let's say, okay, solve the question when k is equal 1 and k equal negative 2 and k equal 3. So you need to rewrite the questions, okay, as the same thing. So x-intercept 2 and 5. So you take the opposite sign, x negative 2 and x negative 5. Okay, and k is 1. So this one here. So if you look this one, how we can do it like this one here. Okay, then you can convert it to standard form by using distributive property. Okay, same thing here when k is negative 2. So we just put negative 2 here and x minus 2. And here same thing, x minus 5. Okay, same thing here. It should be 3x minus 2, x minus 5, and use the distributive property, and you get this one here. Okay, so here also there are some questions. Try to practice on them, and that's it for it. I hope you understand that 7.2. It's easy, simple lessons. Thank you. Have a good day. Bye bye.